Greetings and hello. Today we're going to be looking at functions and not just any functions, but doing transformation on functions. So family of graph includes graphs and equations of the graph that have at least one characteristic in common. So we're going to be dealing with families of graphs as we're doing these problems. And then our parent function is the simplest of the functions in the family. So when we're looking at the family of graphs, the one that's the simplest is going to be our parent function. And this idea falls under the umbrella of transformation. A transformation moves the graph on the coordinate plane, which can create new linear functions. So let's take a look at the first type we're going to do. We're going to do vertical translations. So the graph of g of x equals x plus k is the graph of f of x equals x translated vertically. So if k is greater than 0, we're going to shift everything up. If k is less than 0, then we're going to shift everything down. So let's go ahead and try a problem out. So I want to describe the translation in g of x equals x minus 2 as it relates to the graph of the parent function. So the parent function would just be f of x equals x. For our problem, we have g of x equals x minus 2. So remember that this idea right here comes from x plus k. So if this is plus, this would become minus 2. So my k value for this problem is going to be negative 2. Let's graph this. So I'm going to start off with graphing my parent function. So when I graph the parent function, I'm going to put a point right here at 0 because that is what the y-intercept of this is. So we could put x plus 0. So we looks like y equals mx plus b. And then the slope is up 1 over 1, up 1 over 1, up 1 over 1. That would be the slope for this problem. So that is my parent function. Now I want to graph this new one. So this new one has a y-intercept of negative 2. It has a slope of 1 over 1. So I'm going to come up 1 over 1, up 1 over 1, up 1 over 1. And there would be my new linear function shifted down 2. The other type of translation that I have is horizontal translation. And this is if g of x equals x minus h. And then if h is greater than 0, we have our parent function again. And then we would shift it to the right. If h is less than 0, then again we would have our parent function and we'd shift it to the left. So again, for this one, it's h or x minus h. H is a negative this time. So we're going to use that to help us out. So let's take a look at example 2. So we want to determine the translation in g of x equals x plus h if it was related to the function and the parent function. So the parent function again is going to be f of x equals x. This one is a horizontal. Since it's horizontal, then this is going to be g of x equals x minus negative 5. Because x minus negative 5 is just x plus 5. It's just a different way of writing it. So my h value for this one is going to be negative 5. And as we saw up here, that means it's going to be a shift to the left. So let's draw this out. So I'm going to start off with my parent function. My parent function starts at 0, up 1, over 1, up 1, over 1, up 1, over 1. That would be my parent function. For all these, they're pretty much going to be copy-pasted for the parent function. It's always going to be f of x equals x. Now, let's go ahead and graph our new function. So I'm going to start at 5, because that's what it is, x plus 5. I'm going to come up 1, over 1, up 1, over 1, up 1, over 1. And that would be my new one. Again, notice how it is shifted from my original function to the left, because it is h equals negative 5. And when h is less than 0, then it's going to shift to the left. So this is translations. The next idea we're going to look at is a dilation. So for dilations, we have vertical dilations and we have horizontal dilations. For vertical dilations, we have g of x equals a times x, and f of x equals x. And it's going to either shrink it or it's going to compress, or stretch it, or it's going to compress it. So here is our original function. If the absolute value of a is greater than 1, then it's going to stretch it out. It's going to make it longer. Where here, it's going to be between 0 and 1, meaning it's going to be a fraction less than 1, so it's going to compress it. It's going to make the graph tighter. So that's vertical. What about for horizontal? Well, similar to vertical, horizontal, g of x equals a times x. It's either going to stretch it or it's going to compress it. When a is greater than 1, it's going to end up stretching out the graph. When a is between 0 and 1, or a fraction, it's going to end up compressing the graph. And these are the ideas for dilation. So go ahead and review through these notes and have a great day.